All right, talking about integrals with the natural log function, these are very, very closely related with the derivatives of the natural log function, so I'm not going to dwell on that a whole lot. Basic concept is you're looking for u prime over u, and then you're going to turn that into ln u. And we'll look at that here in a moment, but that's, again, I think it's pretty straightforward from the derivatives. So I want to do one of the crazier examples, or I guess more pain in the rear end examples that they're talking about. So if indeed I'm looking at something like this, all right, notice a couple things. One, this denominator is not a simple monomial. It's not a simple x. It's not a simple rad x. It's not something we could just separate all these parts and then simplify them before taking the integral. All right. Also notice that x minus 2 is not the derivative of this top. This top would be 4x plus 7. I can't even divide anything. Not like a u prime that I could do some sort of u sub. So sadly, since it's not a monomial divisor, it's not in the form of u prime over 2, it's not set up well for a u sub, I'm going to have to try something called long division, if you can remember that from algebra 2 or even pre-calculus, you might have looked at it. So 2x squared plus 7x minus 3 divided by x minus 2. Here you'll see an example of doing it long division. Here you'll see an example of doing it synthetic division. If you have a simple x and a simple non-zero, or I'm sorry, a 1 as a coefficient out here, you can use synthetic. If not, you may have to resort to long division. So, how many times does x go into 2x squared? It goes in 2x. Then you say 2x times x is 2x squared. 2x times negative 2 is negative 4x. And this is the step in the division process where you subtract. So you have to distribute that negative sign across. 7 minus a minus 4 is 11. How many times does x go into 11x? Well, that's 11 times. Then you multiply 11x minus 22. This is the part in the division process where you subtract. So that's actually plus 22, which gives us a 19 remainder. So what does this look like? It looks like 2x plus 7, and then the remainder goes over top of the dividend here, all right? Dividend, divisor, quotient. This is probably called a divisor. So anyway, 19 over x minus 2. So this piece up here, the 2x plus 11, just gets handled with the antiderivative reverse power rule, not hard at all. And then the x minus 2, its derivative is just 1, so I can push the 19 out front, natural log of x minus 2. Talk to me about these absolute value signs here. Just because the domain, we can't take the absolute value of a negative number, so a lot of times they'll just put the absolute values around whatever's left inside here. Sometimes they'll put to the 19th power up here, sometimes they won't. If I had a clue of when consistently they were doing that, I'd tell you, but it doesn't seem very consistent currently. And then here's a look at the homework down here from 5.2. And thanks, and that's all for today.